Good afternoon, teacher Zulaika. Today, we are going to present about 3.3, topic man-made satellite.
I'm Chan Wei Yu.
What will we learn in this subtopic? Firstly, we will learn about 3.3.1, orbit of satellite, 3.3.2, geostationary and non-geostationary satellite, 3.3.3, escape velocity, 3.3.4, benefits and implications of escape velocity, 3.3.5, solving problems involving escape velocity. Your turn, Wei Yu.
First, 3.3.1, orbit of satellite. International Space Station ISS can be seen from the Earth because its large size and orbit at height of 408 kilometers. Centripetal force. Its formula is gravitational force between satellite and the Earth, F equal to gm over r square. Centripetal force on satellite is F equal to mv square over r. Centripetal force is equal to gravitational force, thus V equal to square root gm over r. As gm is constant, linear speed of satellite is only depend on its orbit. Radius of orbit is equal to r plus h, where r is radius of Earth. Therefore, linear speed of satellite v equal to gm over r plus h square root. For example, figure shows a global position system GPS satellite at an altitude of 2,200 kilometers from the Earth. What is its linear speed? Height h is equal to 2,200 times 1,000 meter is equal to 2.02 times 10 power 7 meter. Radius of orbit r is equal to 2.567 times 10 power 7. Linear speed of satellite v, we use formula square root gm over r. We get v equal to 3.87 times 10 power of 3 ms. What will happen if the satellite's linear speed is less than the required linear speed? The satellite will fall to a lower orbit and continue to revolve towards the Earth until it enters the atmosphere. When it enters the atmosphere, its high linear speed will cause it to burn because of friction between the satellite and the air. The next topic, 3.3.2, geostationary and non-geostationary satellite. Satellites have been divided into two types, which are geostationary satellite and non-geostationary satellite. For geostationary satellite, it located in a special orbit named the geostationary Earth orbits. It moves around the Earth in the same direction as the direction of Earth's rotate on its axis. Its orbital period is 24 hours. A geostationary will always above the same geographical location. For non-geostationary satellite, it normally in a lower or higher orbit than the geostationary Earth orbit. Its orbital period is shorter or longer than 24 hours. It will above different geographical locations at different times. Where is the GEO, LEO, MO, and HEO? From the picture, we know that LEO is at 1,000 kilometers from Earth. MEO is 10,000 kilometers from Earth, and HEO is 35,768 kilometers from Earth. Well, for GEO, It is 36,000 kilometers from Earth. It is the extra info about stationary and geostationary satellites. You can also scan QR code from textbook page 105. 3.3.3 Escape velocity. Escape velocity V is the minimum velocity needed by an object on the surface of Earth to overcome the gravitational force and escape to outer space. Formula is distance of an object of the center of Earth is equal to r, mass of the object is m, and object possesses gravitational potential energy is u. The minimum kinetic energy plus the gravitational potential energy is equal to 0. That is 1 over 2 mv squared plus negative gmm over r equal to 0. Thus, v equal to square root 2 gm over r. This is the formula for escape velocity. Escape velocity is only depends on the mass of the Earth and the distance between object and the center of the Earth. It does not depend on the mass of the object. This is the way to calculate the escape velocity of Earth. The mass of the Earth, m, is equal to 5.97 times 10 over 10 power 24 kilogram. The radius of the Earth, r, is equal to 6.37 times 10 power of 6 meter. The escape velocity of Earth, we use formula v equal to square root 2 gm over r. We get v equal to 11.2 kilometer over kilometers of second
Per second.
per second.
3.3.4 Benefits and implications of escape velocity. Firstly, layer of atmosphere. High escape velocity of Earth, which is 1100,200 meters per second, is able to maintain a layer of atmosphere around it. Molecules will only move at 500 meters per second, which is lower than the escape velocity of Earth. So, air molecules that move randomly will be trapped in the Earth's atmosphere and will not be able to escape into outer space. Secondly, aeroplane. A high escape velocity can ensure the aircraft or fighter jet will not escape into outer space accidentally. Speed of commercial aircraft is 250 meters per second, while speed of fighter jet is 2,200 meters per second. As their speed is lower than the escape velocity, so they will not escape to outer space. Third, rockets. High thrust produced by large quantities of rocket fuel will make sure the rocket can be sent into space by achieving the escape velocity of Earth. Now, I'm going to talk about 3.3.5, solving problems involving escape velocity. Example 1. The moon and the sun are two bodies in the solar system. The table below shows the values of the mass and radius of the moon and sun. Firstly, we need to compare the gravitational acceleration on the moon and the sun. And the second question is escape velocity from the moon and from the sun based on data provided in the table below. First question, gravitational acceleration is calculated using the formula below, g equals gm over r squared. The moon's gravitational acceleration, using this formula, we will get g equals to 1.62 meters meter second power negative 2, while the gravitational acceleration of the sun is also calculated using the same formula, and we will get g equals 274 meters per second power negative 2, using this formula, which is g equals to gm m over r squared. The second question, escape velocity is calculated using the formula v equals square root gm1 over r. The moon's escape velocity is calculated using the formula, and we will get v equals 2.37 times 10 to the power of 3 meters per second, while using the formula to calculate the sun's escape velocity, we will get v equals 6.13 times 10 to the power of 5 meters per second. Using the formula that I stated, v equals gmm gm1 over r. The moon has a low gravitational acceleration and escape velocity because the mass of the moon is smaller than the mass of the sun. The sun is the largest body in the solar system. Gravitational acceleration on the Sun have the highest values compared with those of the Moon as well as other planets such as Earth and Saturn. Now I'm going to talk about formative practice and extra exercises. Formative practice 3.3. First question, compare and contrast the geostationary satellite and non-geostationary satellite. Their similarities is they both orbit the Earth and use the formula V equals square root gm1 over r and use the formula T equals square root 4 pi square r cubed over gm. Their differences is their time working, place working, and direction of motion. For the geostationary satellite, T equals 24 hours, while for non-geostationary satellites, T is shorter or longer than 24 hours. Place working for a geostationary satellite is above the same geographical location, while for non-geostationary satellite, its place working is above different geographical locations. For the direction of motion, for geostationary satellite, direction of motion is the same direction as Earth's rotation, while for non-geostationary satellites, its direction of motion need not be the same as the direction of Earth's rotation. The second question, what factors determine the linear speed of satellites orbiting the Earth? The answer is radius of the orbit. Third question, state two factors which influence the value of escape velocity from a planet. The first factor is the mass of the planet and the distance. The first factor is the mass of the planet, and the second factor is distance of the object from the center of the Earth. Fourth question, discuss whether escape velocity from the Earth for spacecraft X of mass 1,500 kilograms is different from spacecraft Y of mass 2,000 kilograms. The escape velocity of both spacecraft are same. It is because the escape velocity does not depend on the mass of the object. Question 5. Proba 1 satellite orbits the Earth at a height of 700 kilometers. What is the linear speed of this satellite? G equals 6.67 times 10 to the power of negative 11. Mass of the Earth equals to 5.97 times 10 to the power of 24 kilograms, while the radius of the Earth is equal to 6.37 times 10 to the power of 6 meters. We're going to use the formula V equals square root gm over r plus h. And we will get the answer V equals 7.504 times 10 to the power of 3 meters per second. Now I'm going to talk about the extra questions. What is meant by escape velocity, which is the definition of escape velocity? Escape velocity is the minimum value needed by an object on the surface of Earth to overcome the gravitational force and escape to outer space. Second extra question. An object is launched with a velocity v from the surface of the Earth. Given that the mass of the Earth is 5.97 times 10 to the power of 24 kilograms and the radius of the Earth is 6.37 times 10 to the power of 6 meters, calculate the escape velocity of the object from the Earth. Once again, we're going to use the formula V equals to 2 gm over r. We will get the answer V equals 1.12 times 10 to the power of 4 meters per second. After this, what we are going to look at is what will happen to the object if it's launched at velocity v. If the v is less than square root gm over r, the object will fall back into the Earth. If it's equal to square root gm over r, the object will move around the Earth. If the v is greater than square root gm over r, the object will fly out to the outer space. That's all for our presentation. Thank you.
Thank you.